Hello, welcome to a new video. This video is for Algebra 1. It is a part of Unit 3. We're on Lesson 2 of writing linear equations, and in this lesson, we're going to learn what to do when we are given a point and the slope. One of the things we can do if we're given a point and a slope, and we're being asked to write a linear equation. So let's check it out. So a recap of linear equations, we have this thing called slope-intercept form, which is super helpful because it's really easy to see what the slope and y-intercept of a line is when it's in slope-intercept form. It's whatever m and b are in this y equals mx plus b that we've got. So in 3.1, we looked at what if they basically just tell us what m and b are, either just outright or from a graph or even in a word problem. Now, though, we're going to make it a little different, and we're going to know the slope but not know the y-intercept. Instead, we're going to know just some random point that is on the line, and that's going to be the information that we can use to go back and get b. So let's try it out. We got some steps here, actually, that once you've gone through a problem, these steps would make sense. By the way, if you would like a free notes page to download and use as you work through this, you can click the link in the description or that may be floating above my head and go get a free notes page from my website. I'll also have a free practice page as well. So let's see here. We want to look at the example and say it says the slope is 1 and the line goes through the point 4, 3. So what does that mean? I know. It means I know that m is 1. And then here's the thing that we got to wrap our heads around. In y equals mx plus b, we normally leave y and x as y and x. But those also refer to x values and y values. In order for 4, 3 to be on this line, it has to be true that if I make x be 4 and y be 3, that everything about the equation works out. So that's what we're going to do, is we're going to say, okay, this is an x value and a y value, and I'm going to plug that and m all into y equals mx plus b. When I do that, the only thing I won't know is b, which means I'll be able to solve for b. So let's try this. Y is 3, m is 1, and x is 4, which means that I'm going to solve for b by saying, okay, first off, what's 1 times 4? It's 4. And then I'm going to subtract 4 from both sides and get that 3 minus 4 is negative 1 because 4 was the bigger number and is negative. So that means I can now write this in slope-intercept form with m as 1 and b is negative 1. So our answer is going to still be this y equals mx plus b with m and b filled in. Even though earlier we did put something in for x and y, we're not going to do that for our answer. So this is y equals 1x minus 1, or just x minus 1. If you put the 1 in front of the x and leave it, that's fine. But the slightly better technically answer is just to have x minus 1. Y equals x minus 1. So that's the step. So label what you need to label, m, x, and y. Plug those in is step 2. Solve for b, that's step 3. And then step 4 is basically write your answer with m and b filled in. So we've got a number of examples here. At some point, I would expect you to feel confident enough to work through some ahead of me, so by pausing the video. But the last two are a little bit different, so keep that in mind, that if you get to example 4 and 5 and get stuck, totally understandable, and just go to that part of the video and get unstuck. All right, example 1. So we've got a slope of 2, so that's m. We've got our point xy. By the way, there are other ways of doing this. You could always graph it, and you could think about, well, if this is the point and this is a slope, you could draw out the slope until you got to the y-intercept. And that would be one way to figure out what the y-intercept is. There's also another form that we'll talk about in a later lesson that can be helpful here called point-slope form. The third way to try to do it is to kind of try to visualize it in your head instead of actually graphing it on paper, to say, okay, if the point's over at -6, -8, I have a slope of 2, like just trying to imagine in your head what that means as far as the rise over the run goes. So of those ways of doing it, I think I like this way that we're doing it, where we're working it out. Graphing, I think, would be my next best choice. I think doing it in your head like that works, and as long as it works for you. If it's working for you, go for it. Okay, so example 1 here. Again, m is 2, x and y are -6 and -8. So we're going to do -8 equals m, which is 2, times x, which is -6, plus b. And so that means we're going to do -8 equals -12 plus b. And then we will add 12 to both sides and get 4, positive 4. So y equals the slope, which was 2, so 2x plus 4. That's our answer. Let's look at another one. This one has a fraction, so that could throw you off here at the beginning of just going, oh no, this is going to make it harder, right, that we've got a fraction, but I'm sure we'll manage okay. We want to plug in m, x, and y, so let's see, 2 equals -4/3 times -3 plus b. I kind of wrote that -3 funny because I know that since I want to multiply these two fractions together, I want to put this over 1. When I do -4/3 times -3 over 1, I can cancel out these 3's. It doesn't cancel out the negative. It would make this basically be -4 over 1 times -1 over 1. And so a negative times a negative gives you a positive 4. And then we just need to finish this by subtracting 4 over so that we figure out what b is. If this part with the fractions confuses you, then you can, instead of canceling at the beginning, you can just multiply the numerators together and get a 12 and the denominators together and get 3, and then simplify it that way. And again, the negatives should multiply together and cancel out, and that should still give you 4. But those are kind of our 2 ways of multiplying fractions together. So subtract 4 and get b equals -2. So our answer is y equals -4/3 x minus 2. Ta-da! Example 3. So we've got a slope of -1, and it goes through the point 10, -10. You do want to watch out and make sure you put the x where x is and y where y is. It can be easy, especially if they're the same number or like opposite signs like this. It could be easy to mix them up. We want -10 equals -1 times +10 plus b, because it's y equals mx plus b. So then I want to do -1 times 10 is -10. And then I want to move the -10 by adding 10 to both sides. So that means that I'll have b equals, well, what is -10 plus 10? If you're worried because we had those equations where we canceled things out and we got no solution, that's not what's happening here, because we still have b. b equals something, whatever -10 plus 10 is, which is 0. So really b equals nothing, because that's what 0 is. But anyway, because of that -10 plus 10, those cancel each other out, but in such a way that we still have 0. We don't have some weird situation here where we got undefined. We can't get, well, we shouldn't end up canceling out our variable and getting some equation with no solution here. That shouldn't be happening to us. So we get y equals, you could write -1x plus 0, or an even better way to write it would be to just say y equals -x, because we don't need the 1 in front of x, we don't need the plus 0, but both answers are technically correct. So there are times in math where if you have a little bit more understanding than just having it kind of memorized and like kind of the method in particular memorize, if you actually know why it works the way it does, you sometimes can get out of doing unnecessary work. And this is one of those situations. We can do this problem just like we did the previous problem, where we say, okay, it has a slope of 0, so that's m. We've got our point, xy. We can plug this in to our formula and figure out that b is -4. And then plug that in and get that our slope-intercept form is 0x minus 4, which is really just y equals -4. I went through that kind of fast. It's my hope that at this point you're pretty good with the steps along the way. But here's the thing. If we had thought about it at the beginning and said, wait, a 0 slope is a horizontal line. Whoops, not a great vertical axis there. A 0 slope is a horizontal line. It says the point 1, -4, so that's here-ish. So we're talking about a horizontal line like this. Do you remember from an earlier lesson what kind of lines or what kind of equations went with a horizontal line? Those lines were y equals a number, because it's saying that whatever our y value here is, whatever this y value is, it has to be that y value all the time, no matter what the x value is. So if we'd realized that's what was happening at the beginning, we could have just gone straight to the answer and said, oh, I know what this is. So kind of our conclusion to draw from this example is that if the slope is 0, our line is going to be y equals whatever the y value of the point is. That's what's going to tell us, where our horizontal line is, which is pretty cool that we can just kind of skip all that work if we understand what's going on. What's also cool is we can do that for undefined slopes. What's less cool is that there's not actually a good way of doing this other than using that knowledge that we were supposed to use, that we could have used an example for, because we look at this and we say, okay, we have an undefined slope. You can't plug in undefined as a number into a formula and get an answer. You can try, but I don't think it's going to work out super well. If all else fails, a strategy you could have is that if you try to put undefined in, you could go, wait, this doesn't work. That's because this is x equals something. An undefined slope, if we remember back, is a vertical line. This point's at 2, 7. So this is a wonderful vertical line. This vertical line goes through 2 on the x-axis. So our equation is x equals 2. But we can't put it into slope-intercept form if it doesn't actually have a slope. Having a slope of 0 is different than having an undefined slope. If our slope is 0, you could say we have no slope, but what you actually mean is just that we're not going up or down. When we say we have an undefined slope, we're actually saying, okay, it doesn't work to talk about this slope. And I know that's kind of a weird distinction to make, and you may be thinking that's kind of a potato thing, and that's fair. But you've got to come up with some way to get your head around this that makes sense, or at least I would recommend that you do that, because if you do that, if you can internalize this and make it to where your brain just is like, this is the way the world works, vertical lines are x equals a number, horizontal lines are y equals a number, then it's going to make the rest of math easier, because guess what? Vertical and horizontal lines are going to be a thing for the next few years of math, at the very least, I would say. So that's example 5. I've got one more here, and now you try, and I would love for you to pause the video, try this, and then leave me a comment with your answer. And I'll go ahead and tell you the answer so that you know how to do it and if you got stuck, but pause the video now. All right, welcome back. So this is m, x, and y. So -7 equals -3/5 times 5 plus b. So these 5s are going to cancel out, but this time we have one negative, not 2. So I'll make it be -3 plus b. We're going to add 3 to both sides and get -4 again. So y equals -3/5 x minus 4. is our answer. Thanks so much for watching, and I hope that you'll join me again for the next lesson. As always, like, comment, subscribe, all that jazz, and just have a great time with your math stuff. Thanks. Bye.